Welcome to my talk about new transports in Samba. My name is Stefan Metzmacher. I'm working for Samba and CERNET in particular. I'm doing development for customers and so on. So the topics for today are a rough overview of our existing transport in SMB, then an overview over the new transports which evolved over the years, then how I implemented quick support in Samba using the quic.ko in Linux and also in user space, and how we test this, and then some outlook on my current development on SMB-Direct support. So basically SMB versions 1, 2, and 3 operate on a message-based transport. So each message transports one or more SMB PDUs, which can be compounded. But the transport sees just one message. The old transports used by Samba are MBT, NetBIOS over TCP. This uses port 139, and it has a very simple message header, 4 bits of type, 8 bits of type, 7 reserved bits, and then 17 bits of a length. And there's a simple exchange at the start of the session where the client communicates his own and the called name to the server, and the server says yes or no. But the more important thing is the message headers for the payload, which are type 0. So basically, with all the reserved bits also 0, we have 17 bits of length, which is up to 180K, 28K. And there's also a keep alive message in the protocol with type 85. Then over the years, direct TCP support was added. This is port 445, which is the common one, which is used today. And it skips all this first exchange and the keep alive and so on, and just relies on TCP keep alive, and it just has one message header, 8 bits of 0 and 24 bits of length. So we can send messages up to 16 megabyte. And in Samba, basically both operate on BSD style sockets for TCP. And the implementation on top of this is, because the payload headers are very similar, it's just the limit of the packet size, which is different. So basically the code is exactly the same. Then SMB-Direct was added back in 2012. It's basically a tiny little wrapper around RDMA and IB-verbs APIs. It supports InfiniBand, Rookie, V1 and V2, and iWarp. And it's a message-based protocol implemented using send and send invalidate verbs. And the send verbs are also message-based, but they only allow a very small message size. So what SMB-Direct is doing, it reassembles packets into larger buffers in order to have the upper layer support up to 1 megabyte typically, and RDMA read and write verbs are used for out-of-band bulk memory copy in order to avoid message copy and message processing. And yeah, by the way, the name SMB is very misleading, and it doesn't have anything to do with SMB, but that's the way it is. It was basically introduced in Windows 2012 together with multi-channel support, and typically the client starts with a TCP session, asks for the server IP addresses and interface details, and then if it finds interfaces capable of RDMA, it then connects to that interface via RDMA. And yeah, it only uses IP addresses. So for raw InfiniBand, it requires IP over InfiniBand. So as I said, SMB3 read and write can be offloaded with RDMA read and write, and it's a bit confusing sometimes, because the client tells the server what to do with its memory, and basically for all RDMA operations the server is the initiator, while the client for an SMB2 read asks the server to do a write, and for an SMB2 write it asks for an RDMA read. That's typically a little bit confusing. So then in the last few years there was a new transport using the quic protocol, which is a rich stream protocol based on TLS 1.3 and UDP. It was designed for HTTP3 with security, performance, and robustness. In order to go through firewalls, it uses port 443, and so it's very easy to tunnel a lot of things through it. And it supports the application layer protocol negotiation, which is basically a string for the application you want to connect to, more or less like a new port space behind port 443. For HTTP, it uses H3. For SMB, just SMB. And for SMB, we only use, or Microsoft only uses a single logical stream, while in theory the quic protocol supports multiple logical streams, bidirectional or one-directional, over the single quick connection. Yeah, Windows 2022 introduced that as a transport for SMB3, and clients typically try TCP first and fall back when there's no response after a few milliseconds, I guess. Yeah, only a single stream is used, and the good thing is that it's also a stream-based protocol below, and so it's basically the same as TCP, and we have this little message header on top of it, also with just 8-bit 0, 24 bits length, so it's basically the same processing above the transport layer. But the tricky thing is that clients can only use it with a name and not with IP addresses in order to do the certificate mapping. And in the first version, the SMB encryption, if it was required, was done in addition to the quick transport encryption. With Windows 2025, there were new features introduced. So there's a way to avoid the double encryption. So the client and server can negotiate that they don't need that, and then basically the SMB layer. Yeah, one question?
Yeah, you have a bullet that mentions that SMB3 over quick uses only a single logical stream.
Yes.
Have you considered using multiple, and if so, or if not, why only one stream? Is there some limit, or what was the reasoning around that?
So the question was why only a single quick stream is used for SMB, and the question would have to go to the Microsoft team, but I guess it's very simple for simplicity, and and the thing is that the SMB protocol itself has multi-channel support, so in theory it could be moved at this layer, but I guess for the start it was just made like this in order to just have a way to go through firewalls and maybe. Okay.
I think there is simplicity. We unsurprisingly forked the TCP WinSocket implementation. The way the code is structured, again, not surprisingly, this is pretty standard code basis. We have a transport layer, and that tracks away a socket, maybe a TCP socket, WinSocket, or an RDMA socket. So if we were to share streams or connections outside of that layer, that means we break the abstractions for us.
Okay.
So normally if you do TCP, we have one TCP socket, we can have streams over TCP, even though you can't have a quick. So again, for simplicity, there's some abstraction on the socket. For a TCP socket, it's just a WinSocket socket. For a quick transport, it is a quick connection plus one stream.
Okay, thank you. So there was an answer from Microsoft guys. So the reason is that the SMB layer has the abstraction of a single connection, and changing that would break that. So yeah, and the other new feature was that a server can require client certificates in order to be more secure. So there's a quic.ko module for the Linux kernel. It's currently out of tree, but it's to be submitted into mainline, and it provides an API basically allocating an enet or enet6 address family with stream socket, and then it uses the IP protocol quic, which is not really a real protocol, but just some magic number within the Linux kernel in order to use this other kind of protocol. And that way you can open such a socket, and from user space you need to do a few calls with quick handshake. That means there are a few out-of-band messages between kernel and user space in order to negotiate the crypto keys and so on. And after that, it's just an ordinary stream socket for user space. There are ways to use multiple streams there, but as default, it's possible to have just one, and then you can just use it as a TCP socket. So the changes to Samba are very easy, not very complex. Basically, we just need to replace IP proto TCP with IP proto quic, and set up some GNU TLS structures, call the quick handshake on startup, and from there everything is the same as with TCP. The most complex thing was to pass the transport type through all the layers in Samba inside, and have configuration options for the transports. So just the magic around it and having SMB status showing that it's a quick transport. That was the most complex code change. Yeah, as I said, hopefully that module will be mainlined soon. There's a V2 under review, and maybe one of the next releases will pick this up. So in order to provide quick support even without kernel support, one can use some library that implements quick in user space on top of UDP sockets, and we try to do that with libng TCP2, which is a quick implementation, and it is. Ralph, one question?
Just a quick question. It's a little bit confusing because you're saying consistence without quick support, because it's saying there consistence with quick support, right? So that's probably just a typo, right? It should read without?
Yes, it should. Yeah, thank you. Without, yes. And yeah, the libng TCP2 can hook into various crypto libraries, and as we are already using GNU-TLS, we use that. And yeah, basically we do the same handshake in order to set up the crypto stuff, and then we can operate non-blocking with callback APIs. So it's easy to use in Samba for the client side, because it only operates as a single process in user space, and we can have a single UDP socket there, and we combine that nicely with our T-Event and T-Stream infrastructure. So it was relatively easily to exchange the code to be abstracted to use TCP sockets, quick kernel sockets, and this user space quick abstraction. But for the server, it's not so easy, because we currently rely on FD parsing for stream sockets in order to have multi-channel support. And that's not possible with a simple UDP socket. So we don't have that and rely on the kernel support for the server. And then in order to have some new features in Samba, we typically try to have regression tests, and we use a socket wrapper library and some other UID wrapper and resolve wrapper and so on, in order to do our self-testing. And in particular, socket wrapper can emulate UDP and TCP sockets based on using Unix domain sockets on the lower layer, and it's just injected with LD preload into any binary without recompiling. And yeah, I added some support in order to do a quick socket and use sec packet sockets. These are basically like UDP sockets, but one FD for a logical connection, and that's basically what we really need for testing. And above that, I added a quic.ko wrapper, which just simulates the API the quic.ko kernel module also provides, and makes use of this socket wrapper feature with the sequential packets. And the crypto is also using the libng TCP in order to just rely on two things, just the kernel support and libng TCP2. This has some limitations because the event handling is a bit tricky and so on, but for the typical or some basic tests and regression tests, that is more than enough, and it works quite nicely. Yeah, and we are doing all sorts of combination in testing in our code, just testing with quic.ko wrapper and on the server and on the client we use both combinations. We have with quic.ko wrapper and also with the user space libng TCP code path. So we have both tested. Okay, the next project I currently working on is SMB-Direct support. And yeah, in the Linux kernel we already have SMB-Direct support for the quic.ko, the RDMA mount option for the client, and with the kernel KSMBD server it just uses all available RDMA interfaces. But the thing is that both were copied from each other, but then developed in other directions. So we have almost the same code twice, but some bugs are there and some bugs are there, and it's a bit confusing. And yeah, for quite some years I was working on a prototype for an protocol family SMB-Direct with an SMB-Direct KO. That's a standalone code, and it's basically a prototype, and I was able to have Samba to use it, and it basically worked, but there were some corner cases where things were still not working. But yeah, in order to get something upstream, and we have the goal to have just one implementation for the kernel client, kernel server, and user space. And yeah, we basically agreed on abstracting and merging the existing code first, and then improve from there and provide socket APIs. And that's much better than having a flag day switching the implementations from one to another. Yeah, I set up the project, went on and thought, yeah, it should be easy. But the first thing was to get the existing code working at all, because there were regressions and crashes here and there, and it took quite some time to get a state that can be used stable for testing, so that I can test before a change and after a change, and when the test passed, then I'm confident that I didn't break anything. Yeah, I do the testing with XFS tests, and from time to time I add more tests. But typically it's not very important which tests are running, because the SMB layer should work more or less the same with TCP and SMB-Direct. So it's just not required to have the logical SMB layer checking done for all this, because some tests run really, really long, and I try to do the short tests which just take a few seconds, and so that I have a full run with about 10 minutes or so. Yeah, the work to use some common structures between server and client, that's finished, and it's in Steve's for next branch to be added to the 6.18 kernel. And the next step I'm working on currently is to move things into a common area where we have common functions, and basically I copy one function from the client, for example, copy to the common area, look at the difference for the server code, make sure that both are handled, and then do a few cleanups and reformatting and nice error checking and so on. And then have a separate commit for the client that just makes use of the new function. Same for the server, and that goes on and on. And I guess I'm almost halfway through it, but yeah, it's still a bit work to get there. So once I've moved all functions, then we will get an SMB-Direct.ko, because for now I inject the common functions via including .c files, which is not the greatest way to do it, but it allows me to do this micro commits and use just one commit per function, which makes it easier to review and test. And once we have that and everything is in common, then we have just the few functions which need to be accessed by the SMB layer, and these will be exported from a common SMB-Direct.ko. Yeah, once we have that, I will hopefully finally be able to add some socket abstraction, and learning from the example of quic, instead of adding a new protocol family for SMB-Direct, I think I will go with an IP proto SMB-Direct, because it uses IP addresses anyway, so I guess it will make it easier, and also hook into some BPF-based common handling of iNet sockets. Yeah, in order to make it easier for user space to use, and even for the client, for the kernel stuff, I will just add this 4-byte length framing we have for all other transports. It's not, so it basically makes it easier to consume outside or above the socket layer. Yeah, and from there it just looks like TCP and quic. In order to do some zero copy improvements to avoid data copies, I will later use IO with send and receive zero copy. And for the RDMA read and write, we will use some IO command, which is basically an ioctl style command, so that we don't have to do more copies than needed there. Yeah, and having that IP proto SMB-Direct will also allow us to do some standalone testing. So currently we only test with quic.ko and KSMBD or against the Windows server, and doing low-level socket testing and test all the features and all edge cases and so on. It would be good to have a standalone test suite. So if someone wants to do modifications to the code, we can just run the test suite, and we'll be able to see that it will still work. And we could even add it to tools like iPerf or so, in order to measure the low-level speed of the transport. So when we have that, I can start to change Samba to use it, and luckily it will be very easy for the main transport thing. So it's basically the same as TCP and quic, just adding a new transport type, doing some other setup code, but basically it wouldn't be much change at all. The only thing that requires some more code would be the RDMA read and write offload, but that's also not too much. As I already have a prototype using my old SMB-KO module, it should be very easy to do. And then we would also be able to write some SMB torture regression tests and run that against Windows in order to see how things have to behave. And finally, similar to the quic.ko wrapper support, we would have an SMB-Direct KO wrapper for testing. And I guess we would able to use something like process VM read and write v in order to simulate the RDMA read and write from the server process to the client process. And with that, I'm done with my presentation. Any questions? Okay. Okay. Okay, thank you.
So I have a very quick question. So
Okay.
one of the things talking with the Microsoft quic developer, he had some frustrations about this, and it reminded me of my grad school days in the late 80s when our professor was showing us how terrible TCP was. And we were reading research papers from Stanford and USC showing why TCP is awful and don't use it. And obviously quic over UDP deals with a lot of those head-up line blocking and all those kinds of things. And so they had a mode where they could turn off encryption. We could just use SMB encryption and just, they had a mode. And it got turned down in the standards committee, but they decided to have, I think they have a test mode in Windows where you can disable encryption. And they were doing, this was just casual developer talk, but it was faster in a lot of workloads to just run over quic unencrypted than it was to run over TCP. And obviously last year at SDC we had the HOMA talks, the Stanford guys working on an alternative to TCP. But I got to thinking, if we can fix these performance problems with quic driver in the kernel, over time, we may have cases where we could turn off encryption, use SMB encryption, which is probably faster than TLS, right?
It's basically the same. It's also AES GCM, I think. So the question or remark was that Windows has a mode in its quic driver to turn off encryption and just use flow control and other things in order to see if it's faster than TCP with all the problems TCP is having. And in the development I did, I have a benchmark testing how much requests and responses I can get with just SMB keep alive against a Windows server. So I didn't do this on bare metal, but just between VMs. So it's but still there. Often the amount of requests per second were faster using quic, even with encryption, than using TCP.
Interesting.
And I don't yet know if it was a restriction on the client TCP stack or on the server, but it was
interesting. Well, talking with the Red Hat guys, the SAP engineers who did kernel for forever, their performance test had plenty of benchmarks where they were showing it faster than TCP. Now, admittedly, these are biased, right? I mean, they're narrow tests, but it got me super excited because I kind of felt like remembering back, my prof the next year went off to lead the IPv6 effort, so I didn't get to talk to them anymore after that, but my strongest memory of TCP is how it sucks. And so this is kind of nice to finally,
Yeah.
head of line blocking, no parallelism, congestion control issues.
Any more question?
Question/comment. Again, on abstractions and the Windows implementation. We use MS Quick, which is by itself cross-platform. And in contrast to the WinSock kernel implementation in Windows, one thing it does not allow you to do, they do have experimental support on GitHub. One thing it does not allow you to do is take ownership of the receive buffers or provide your own receive buffers. So the implication of that is you are required to copy the ingress data buffer as it comes in on the Windows. I don't know if this is the /question/comment part. It sounds like there are two implementations of Quick, of Samba with Quick, either with the Linux IP.
Yeah. So to repeat the remark, on Windows the Quick implementation requires an extra copy on the receive buffers, and yeah, in Samba we so our main goal is to use the kernel quic.ko module. So the other thing is just for completeness, for testing, and in order to do some quick support on legacy kernels and also on other non-Linux Unixes, so like AIX and FreeBSD or so. So the real thing that matters is the quic.ko, and I don't know how this would work with zero copy on receive yet. So currently we just do the copy of the receive buffers on like with TCP, and we could optimize there, I guess, but currently it's not there.
It would be, so with the Linux kernel support, you create a quick type socket, you're still using the Berkeley socket interface.
Yes.
And when you call receive with your own buffer that's allocated, the expectation is that the quick support that's in the kernel is just receiving that buffer.
No, it will just, so if you call receive message on the socket from user space, it will just copy over into the user space buffer. But on the receive or internal handling, it will use a separate receive buffer in the kernel. So. More questions? Okay, thank you.